So now that all the holes have been drilled, we are ready to get into actually starting to make this look less like Swiss cheese and more like an actual part. I'm going to start out with a 3D adaptive clearing. I'll grab number 12, which is our roughing it mill. And for the geometry, what we're going to do is we're going to set our selection. I'm going to grab these parts. I'm going to tell it it's anything outside the boundary, which means it will cut everything inside it, but will not cut outside. If we didn't do this, right, the 3D adaptive is going to try to get rid of all the stock. We don't want to do that since we're doing it from a larger sheet that we're going to cut it out of later, right? But it thinks that its goal is just to get rid of all the stock. But we don't want it to get rid of all the stock. We want to just get rid of stock that's unnecessary within the port's outside profile. So that's why we're doing this. Rest machining we will do from previous operations. This will just make it so that it actually looks at where there are holes for it to go into. And also it will not try to kind of cut in a corner where there's a hole. So that will just kind of speed up our cycle time a little bit. For our bottom height, we're going to go ahead and do stock bottom. I'm going negative 0.03. And then for stock to leaf, we will go 7 thousandths on the radial, and we will go 0 on the axial. And we're going to hit OK and see what that generates for us. So we'll give this a second to generate. And I have an idea of something that's going to generate that we're not going to like, but we will see if that does in fact generate how I believe it will. So it hasn't quite finished generating, but I've already noticed a few things that it's doing that I do not want to do. First off, it is not forcing a plunge move, it is forcing a helix, which is okay. That's relatively simple for us to force. But also, it is going into some holes that we do not want it to go into. Just because of how we have set it up, drilling, and drilling out those corners, some of these helix moves we just don't want. So what we're going to do instead, I'm just going to go in here. We're going to do geometry, right? We're going to do, well actually before this, what we're going to do really quickly is just going to go right click it and hit suppress. Right click and hit suppress. You can't suppress it when it's being generated. Okay. Anyway, we'll ignore that for now, and we're just going to go in here and we're just going to grab all of these bearing bores. And this will just isolate them so we don't have to worry about them. The 3D adaptive is going to make us so things generate faster, and also it will make everything a little bit neater for us. And also, the most important thing is we need to have this large bearing bore be separate, since it has this flat pocket kind of edge we got to deal with. In the 3D adaptive, how we're going to do it with a stock bottom on our bottom height, it's not going to treat this this shelf properly, and it's just going to cut right through it. So anyway, we'll go ahead here, we'll put 7 thou, not 70 thou, oopsies, 7 thou on the radial, 0 on the axial, and then we're going to do plunge. We're going to hide the sketch, enter positions, we're going to click these, and then we have 6 chains, and we have 6 entry positions, so that looks good to me. Perfect. That's going to generate, and that generates all fine and dandy. So that's exactly how we want it, and we're going to move on. We're going to put this above our 3D adaptive. We're going to go into our 3D adaptive, and we're going to get rid of these machining boundaries. instead of over reports, we're just going to go and select the actual ones we want to machine. We want to do this one, right? This one, this one. So basically all these that we've drilled with a 266 drill. And we're just going to force it to go inside all these. Right, and it's got 14. So then this is all okay from before. For our entry positions, well, first for a ramp, make it plunge, entry position. We are going to say 1, 2, 3, 4. Yeah, and we have 14 entry positions and 14 machining boundaries, so we shouldn't have missed any. So this will go ahead and generate. So I got an error. I don't know why. We're gonna check this out. So it says feature flag and adaptive turn roughing, which makes no sense because we're doing a 3D adaptive, not a turn roughing, which would be for a lathe. And the error is an internal cam kernel error. Please report 3D. So usually these error codes are a lot more kind of point you at a direction, like a lead fail or something. But in this case, I have no clue. So we're just kind of going to go through this again. One thing I'm going to do just to see, and I'm just going to uncheck rest machining. There's no reason we need to rest machine this at all. So we're just going to see if that works. And we'll go from there. So we finished generating it, and something weird has happened. So it's trying to get around the edges of these pockets, and the reason for that is, once again, the 3D adaptive, the stock that it's spacing everything off of, is only so accurate. So it doesn't know, since we got rid of rest machining, it doesn't know that we came in and we faced this off. So it thinks there's still stock there. It thinks it's the very beginning where we have this 15 thousandths of material above it. We weren't able to use rest machining because I was creating some form of error, but that's okay. We can simply get around this. But also, another thing I notice is in here, it's doing these weird little step downs. So it's going to come in at this height and do this little tiny cut and go all the way out and then go all the way up, all the way back down, little cut, all the way up, all the way down. That's going to just waste a lot of cycle time, and it looks like it's only doing it, it's doing it there too. So it's doing it in a few spots, and what that is that's a fine step down. For some reason, Fusion is thinking that there is a feature here that needs to be used with fine step down. There is not, so we're just going to override that. So we're going to go back into this adaptive once again, and we're going to fix two issues. First off, instead of saying stock top, we're going to do selection, and we're going to grab the top of this face. So that should get rid of that first issue with it cutting on top. Then to get rid of those fine step downs, under our passes tab, here we have our maximum roughing step down, which is 0.3, which is a good, and we have our minimum roughing step down. Our fine step down, that's at the 30 thousandths. So we're just going to get rid of that 0 in front of it, set it to 0.3, the same as our maximum, and that's going to force it and say you can only take a 0.3 step down, or less, obviously, since we're not going fully 0.3, but you can't take like a 0.1 or a 0.2. And we can also see how fast that generated now. And we went from 8.5 minutes to just under 4 minutes by getting rid of those two settings. Granted, most of that was definitely the top height being wrong. However, this is looking very good, and we're going to go ahead and we're going to get into the 1/8 inch tool. So we're going to start by doing a rest machining on this. To do this, we're going to go ahead, we're going to duplicate this toolpath once again, Control T, right? But we don't want a 1/4 inch tool, we want our 1/8 inch tool. So go to our tool library, it's tool 11, we'll do aluminum roughing, boom, geometry, this is all okay. Stock contours is okay. Rest machining, we'll do from previous operations. We're going to click reduce error cutting. That's going to try to reduce that fine step down stuff that we did see. However, we are going to override it manually too. This is all perfect. Since we just duplicated it, this is okay. And this fine step down, it's zeroing out because it is now larger than our maximum. But we will just, oopsies, we gotta put a decimal point in front of that. Toss that in there, and we will be good. Entry positions are saved. And we're gonna call that to see how it generates. Yep, and we can already see, right, on these ones it's just barely rubbing those corners, and on this one it's got to go a lot more. It's going in and it's getting those corners perfectly, and that's exactly what we want to see. It's doing some, you know, a little funky stuff, but it's pretty darn good for what it is. Okay, so now what we need to do is we need to make another 3D adaptive, but this time instead of doing a rest machining, right, we need to get all these spots that have gone that we didn't get in this first round. So to do that, right, we're going to go ahead and it's going to be our machining boundaries. We're going to have to change. So we didn't get you and you. And we're just going to go around and we're going to get all the little cavities that we didn't get the first time around. And see, you, and I think that's it. And then what we'll do is our entry positions, right? We're going to do our best right on these. There's 3 points that we have, you, and you. And then we're going to see if it generates properly. There's a chance it will, and we won't have to mess with it, but there's a chance it won't, and we will have to go in and actually sketch it. But, actually this point is completely off, oopsies. But, if we are lucky, the 3D adaptive should be able to get in there and plunge. But we're going to see how it generates, of course. So it looks like it's doing its job correctly. See, it's going in on these spots that we have cut away. So we're going to simulate this real quick. Yeah, and it's going in there and it's getting those. And that's exactly what we want to see. That's perfect. One thing I am noticing is for some reason on the rust machining, oh, somehow, okay, well, I forgot to duplicate that. That's me being silly. Anyway, I will just have to redo the rust machining really quickly since I overrid it instead of duplicating it when I made that new 3D adaptive. So that's a goof on my part, but it's relatively simple. Go here. Right, make you. This will generate, and then we'll have this generate right after. We're going to simulate real quick on this one, just to make sure we're all good here. And that looks a-okay to me. So now that we're done roughing our part, we're going to move into, I lied, we're not done roughing our part. Forgot about these ones right over here. So we'll grab those real quick. But now that we are actually done with the part, we can start moving into finishing. So the first thing I'm going to do is I'm going to deal with these bearing holes. You, you, you and you, just these two. So to do those, I'm going to do a 2D contour. I'm going to grab our finishing bit, which is tool number 7. Go to limit finishing. And I'm going to click you. On the heights, right, we're going to go stock bottom. I'm going to go negative 0.03. I'm going to do repeat finishing passes, which is also known as a spring pass, and that just means that once it goes around in a circle once, it's going to go around in a circle again, just to combat any deflection that happens. And I'm going to go stock to leave 0 on axial, but on radial, I'm going to leave just maybe like 3/10. And the goal for this is I want to be slightly under the nominal size so that we can have just a slight press fit for the bearing, so it's not all loosey-goosey. But then also, I'd much rather have to rerun the cycle once at the very beginning when I'm dialing in the program on the machine, than accidentally overshooting this tolerance and the bearing just kind of like wiggling around in there, which we definitely do not want. So just kind of prematurely wasting, the 5 minutes it takes to repost this program with a different stock to leave, than risking wasting all the time that we've done of roughing and drilling up to this point, because it's around 30 minutes or so. And we just do this once, we get it right, and then from there on out, for the rest of them, the next 11 times in the cycle, it's spot on. Make sure this adaptive thing, right? So then that's just going to go around, walk around there. Now we're going to do the same thing. I'll just duplicate it. Actually, I'm going to duplicate it this time, but instead we're going to be doing you and in our 2 falcon holes. Now, under the stock to leave, we don't want these to be press fits. We want them to be slight, kind of just a slip fit. So right now they are modeled nominal, like for these falcon holes and for this clearance hole, just for the forks on the swerve. Right, they're modeled to a nominal size. So for like the falcons, it's 3/4 of an inch. But we're gonna go ahead and do a negative stock to leave of just like 1.5 thou, and it's just gonna make these boards just slightly bigger, which we want, especially in the falcons. I find that they are slightly oversized from nominal, probably due to whatever coating they have on it. I don't know if they account for that with their 3/4 nominal size. And you still definitely want these to be snug, but they do not need to be a press fit at all, and they should be easy to get in and out. So those are good. The last part we need to finish with a 1/4 inch bit is going to be this edge right here. And to do that, once again, we're going to do a 2D contour with our same number 7 bit. But then what we're going to do over here, we're going to do roughing passes. We're going to do a maximum step over of, I don't know, we'll do a maximum step over 50 thousandths. What percentage would that be? 0.25 divided by 0.05. That's 20% step over, which is reasonable. And then to start off, I'm just going to say 4 passes. I don't really know how many. Make sure we click repeat finishing pass. And then we're going to, everything here should be good. We're going to hit OK. Now we're going to watch the simulation. And we're going to see that there's definitely too many passes to start out with. Oops, that was way too fast. So the first pass does absolutely nothing. The second pass does absolutely nothing. The third pass actually starts to cut. So that means that in here, another roughing. I can go down from 4 to roughing passes, and we will be a-okay. So we're just gonna simulate this real quick. Make sure. And that looks good to me. Perfect. So at this point, we've finished everything with the 1/4 inch bit, and we're going to go to our 1/8 inch bit. And that's going to be all of these features. So under the 2D contour, we'll actually start by selecting our 1/8 inch bit, aluminum finishing, and then we'll have to select all of these okay. Alright, we'll make the stock bottom. We're gonna go 30 thou under. And that should be it. That looks good to me. So one thing that I just now remembering is we can see, right, we're going tool 12, tool 12, tool 11, tool 11, tool 7, 7, 7, back to 11. So we really want to put these 3 finishing passes before these 2 adaptives, just because that reduces our tool changes, right? Instead of having to go to tool 11, then go to tool 7, then go to tool 11 again, we can just go to tool 11, stay at tool 11. Of course, we could also put this contour above. I do like going from a larger tool to a smaller tool, so I will choose to just go ahead and toss these right above those. Sadly, that does mean we will have to regenerate these tool paths, but they are not taking too long, so it's okay. So anyway, I'll let these generate, and that will be it for this part. And in the next part, we're going to go over kind of just finishing touches. So like chamfer, we're going to get this thread milled for the encoder, and then we're going to actually cut out the part. And that should be the conclusion of these parts.